Hi class, this teacher Metza again. How are you all doing? I hope everybody is fine. As for me, I'm feeling great too. Today's lesson, we will be talking about the industrial application of electrolysis. Now, why is electrolysis being used in industries? Well, there are many benefits, and countries that apply the electrolysis in industrial basis becomes rich countries like China, US, UK, India, and so on. So electrolysis is a very important aspect of producing the desired products, and we will learn more into that later. Before I proceed, I received a question from a student, because prior to this I did show you the electrolysis of molten sodium chloride, as well as electrolysis of sodium chloride in aqueous solution. So there are two ways of electrolyzing sodium. But the question is, why do we have two ways of doing it, and why is that industries prefer to use molten sodium chloride to do the electrolysis rather than using an aqueous solution? Well, there is a very good reason to do that. Now, industries normally will use the electrolysis of molten sodium chloride, because that is the only way they can extract sodium from it. Now, if you were to use the aqueous solution, as you know, when aqueous solution, it involves two other ions, the hydrogen ion and the hydroxide. Therefore, what happened at the cathode? At the cathode, when at the anode rather. Well, at the cathode, instead of natrium being discharged, it is hydrogen that is being discharged. So when you use an aqueous solution at the cathode, hydrogen will be discharged instead of sodium, because of the the position of these ions in the electrochemical series. Now, natrium is at the further top, and nitrogen is far down below. So because of the preferentially discharge of hydrogen, therefore when they use aqueous solution, they will never get sodium, but they will get NaOH, that is sodium hydroxide instead. So if you want to extract sodium, there is no other way. You have to do using the molten form meaning you have to melt the sodium chloride into molten form, then only you can extract pure sodium from that solution. So I hope that answers your question. Alright, Peter. So let's proceed with our lesson. Industrial application of electrolysis. Now, what are the uses of electrolysis industries? Well, there are many uses, and the three most important application is to extract metal from the ore, the impure ore. Number two, to purify impure metals to get the pure metals. And number three is also because they can do electroplating, meaning to make things look better and prevent rust and so on and so forth, which we will go through later. So the application of electrolysis are found in a wide range of industrial processes, and the most common application among which is extraction of metals, purification of metals, as well as electroplating of metals. So the first thing is extraction of metals. Now, electrolysis is used to extract very reactive metals such as sodium, calcium, potassium, as well as aluminium. These are some of the reasons why they do the electrolysis. And secondly, they need to purify metals, and this is usually done on metals such as copper and gold, and they want it to be, as pure as possible. When a metal is certified 99.9% pure, that is literally almost 100% pure, but nothing is 100%. So the best the chemist will say is 99.9%, which is as good as. So as the you can find the pure gold, they have the 99.99% gold. So silver, chromium, and so on and so forth. So in order to get that quality of metal, you need to purify it from the impure metals. Then we have the electroplating, and electroplating is a process of coating a thin layer of protective metal such as nickel, gold, silver, tin, chrome, to beautify things, to make it more attractive. But most important thing is to prevent that original metal from rust, and so on and so forth, which we will discuss later. So reactive metal like potassium, sodium, calcium, aluminium can be extracted from their molten compound by using electrolysis. So in today's lesson, we will be concentrating on aluminium oxide. So where do we get aluminium? Why we want to talk about aluminium? Then in purifying of metal, In the process of metal purification, metal is transferred from anode to cathode. So it's a simple process, but you have to do it correctly using the right anode and cathode to get the desired result. And when it comes to electroplating, it's only a process of coating the surface of a metal with a thin layer of non-reactive metal. Now, like ferrum or iron, being very reactive, they are prone to get rusty. So when they are oxidized, so in order to protect iron from being oxidized, either you cover them with wax. Well, what good is a metal if you have to cover it with wax? So the next best thing, or the better thing to do, is to electroplate iron with something which is non-reactive. So that is the process called electroplating. Well, guys, this is what we are here for. Welcome to Latte Minda. Now, you know, chemistry is cool. And you know what? Chemistry is power. And all the rich countries in the world, like China especially, and US, Japan, well, it is the chemistry that make their country rich and make the people prosper. So we are so far behind. So it's people like you who take up chemistry and eventually become chemists, and we can do all this. We can extract metal, we can purify metal, we can do electroplating, and we gonna develop our people and provide good jobs, you know, and prosper in future. We have all the raw materials, so all we need to do is just produce them rather than importing them from China or from US, from UK, from India, or from Brazil and whatnot. So it is people like you that will be dependent upon by the country, you know, to apply your knowledge in chemistry and to prosper and make the country rich and the people employable and lead a good life. That's what we are here for. So this is what Latte Minda is all about. Alright, so let's go on to the first metal that we are going to talk about. That is a bauxite. Well, many people have heard of aluminium, but not many people know about bauxite. So bauxite is just a mineral where it contains the aluminium ore, or the aluminium metal. So this is how it looks like. In this country we have bauxite, and especially in south, in Johor, plenty of them. But we don't have any aluminium smelters in this country, do we? Why is that? So we just export this raw material to Australia and get the Australian to do it, or export to China. But now China have their own bauxite. They have a big reserve, so they don't need. So one of the example we're gonna discuss is about the extraction of aluminium from its ore, that is bauxite, which contain aluminium oxide, Al2O3, 2 negative. O is always 2 negative. Right, so bauxite is also known as aluminium oxide, which contain aluminium oxide, and the symbol is Al2O3. So in this bauxite, if you look, it doesn't look aluminium because it contains some other impurities such as silica, oxides of iron, and so on and so forth. Then they have silica, they have oxides of iron, and some mud maybe, or whatever. So what we will do is they will extract this, and in order to get this to be extracted, so they have to go to a process, right, to extract this, and the process is none other than electrolysis. So let's have a look how it is being done. So extraction of aluminium metal from the mineral bauxite. So we have a factory with a big container, where they have the big cathode and they have the anodes, bars of them, right, to extract the aluminium. So as you can see, if you want to melt aluminium oxide, it requires about 2045 degrees Celsius. There's awful lot of energy required. So they use another material called cryolite to add to the compound to lower the melting point. So when they add chloride, they will be able to melt this bauxite or the aluminium oxide at 900 degrees Celsius. That is more than half. They managed to reduce it more than half. So you can save half of the energy, right? And the process is to extract pure molten aluminium, and you can see when they separate the pure molten aluminium and the oxygen, the oxide is given off. So oxide will be given off at the anode. So let's go thoroughly. Molten aluminium oxide dissociates into ions. The moment they are melted down, they will get dissociates into ions. So you have the Al3 plus, and you have the O2s, the oxygen. So when Al2 O3, which is the aluminium oxide, the moment they are being melted down, so they will release the aluminium ions and the oxide. Now at the cathode, the Al3 plus, which is the aluminium ion, will receive 3 electrons and transform into its original form, pure form, that is the aluminium, molten aluminium. Whereas at the anode, oxygen gas is released, so 2 oxygen molecule will be discharged, and O2 is formed when they give off 4 electrons. So when there's 2 oxygen release 4 of the electrons, then it form an oxygen atom, and 2 of them combine to produce to become oxygen gas molecule and get released. So by getting the oxygen out from the aluminium, so all aluminium now is literally pure. So you look at the half equation at the cathode and at the anode. Al3 plus in liquid will receive 3 electron and become molten aluminium metal, and at the anode 2 O2 negative two oxygen ions, when they release their electrons, will form oxygen gas O2 and get released. And the overall equation will be 2Al2O3 in liquid will produce 4Al aluminium in solid and 3 O2 gas molecule. So this is the process of extraction aluminium metal from the mineral bauxite. Now I've given you some clear understanding. If you refer to your textbook, maybe you'll get more details about it. So the pure bauxite aluminium oxide is then mixed with cryolite. Mixing with cryolite lowers the melting point of the aluminium oxide. Remember that in order to do aluminium, to get aluminium, you need cryolite. Now the purpose is to save cost, at the same time to make things faster, right? So they will reduce the melting point, and they get the job done faster and slightly cheaper. So this is the result, and when we get this aluminium, now what will they do with the aluminium? Well, you know, the aircraft body are all aluminium, and some engine blocks are also made of aluminium, and some wheels, motor car wheels, are also made of aluminium. The reason being they are light and they are very strong, very durable. So that's the reason why aluminium need to be extracted, so that it can be used for various purposes. Right. Now the second part is about purifying metal. So why do we need to purify metals? Because we want a good quality metal, and when you're gonna mix this metal to form alloys, we need pure metals, right? So when we need pure metals, only we can do mixture, you know, to produce alloys. For instance, you can use iron with nickel. You can use iron with chromium, you know. You can use some other compound to metals to make a new type of metal, which is, you know, stronger and prettier, and it's also anti-rust. Now this is where sodium plays an important role. Now that is the answer why sodium need to be extracted in its pure form, simply because we need all pure stuff to get into a mixture, so that nothing else interfere, so that they can produce new products. So you definitely need sodium to add with iron, to add with chrome, so to get stainless steel, you know. That is the reason why purifying metal is vital in the industrial process, in the industrial community. So here we're going to look at the process of purifying copper. Now why do we need to purify copper? Because, you know, copper being a very good conductor of electricity, and copper are made into electric wires, and we don't want any interference in the flow of electricity, do we? So we need to have a very good conductor, and none is better except gold compared to copper. So if you look at this, all you require is, you know, a thin plate or thin foil of copper as the cathode, and the impure metal copper at the anode, as the anode, you know. So we can also use the electrolyte, the copper to sulfate solution. So of course you will set up your experiment, or if you want to do an experiment, this is what you need to do. Or if you want to open up a factory, this is also what you need to do, right? So a pure copper at the anode, as the anode, it make the impure copper as the anode itself, then pure copper as the cathode. So you can use a foil, a copper foil, a thin one, attached to the anode. Then the copper to sulfate solution, so when you run through the electricity, what will happen? When you run through the electricity, the copper from the anode will dissolve and release copper 2 ions to get attracted to the cathode. So they will release the copper solid, will release copper 2 plus in aqueous. When they get off this, they give off their 2 electrons. So the moment they give off their 2 electrons, they become an ions. So they will flow in the solution and get attracted to the pure copper at the cathode. So that is what they will do. So you can see the anode is being eroded, and then it is being transferred to the cathode. So what happened then? So as given time, then the copper 2 ions will be discharged, and the copper metal is formed, and cathodes become thicker and thicker. At the same time, all the impurities, all the silica or whatever, or we can say the anode mud will be deposited below the anode. So you can get rid of this later on. So at the half equation, you will see that copper in solid, when they have been melted down, they will release copper 2 plus in aqueous, as well as when they release off the 2 electrons, right? Then they will move to the cathode, and here they will attract to the cathode when they when they receive the electrons back. They receive the 2 electrons, and they become solid again. So copper 2 plus aqueous. When they go to the cathode, they get the 2 electrons back, so they become solid again. So from solid to molten to solid. So give off your electron, you become molten. move away. So go to the cathode, take back the electrons, and you become solid again. What a magic, process. And blue solution will remain the same, because the concentration of copper is just the same. Nothing is lost here except the transfer of metal from the anode to the cathode. That is all. So that is purifying of metal. So electrolysis is widely used to purify metals, especially copper and gold. Now in this respect, crude copper extract from its ore is about 98% pure. However, electrolysis process purify copper further to the level of 99.9%, which is suitable for making electrical wiring. So during the electrolysis, the impure metal is made the anode. You don't have to do something, just get the impure metal as the anode, and the pure metal is made the cathode. So then, through the aqueous solution that contain ions of the metal, to make up the electrolysis. So the transfer will happen. So at the cathode, you will see copper 2 ions are discharged by gaining electrons to form copper atoms. Well, at the anode, they are given off, discharged, sulfate. However, the sulfate ion and the hydroxide ion are not discharged. Why is that? Because the position in the electrochemical series is very much higher compared to copper 2. So since copper 2 is not so reactive, so they will get discharged. More so since the anode itself is made of copper, which is not an inert electrode. So the concentration is even higher then. So the copper atoms will ionize by losing electrons to form copper 2 ions. The copper atoms, will get ionized itself and move to the cathode. That is how copper 2 ions are formed, and the anode, impure copper, becomes thinner. You can see the visual here. Then we come to the other part, which is the electroplating. Now you may have a metal mark like this. It may look like brass, it may look like tin or whatever, and it doesn't look so attractive. It looks kind of rusty. If people think this color looks rusty, so you want to beautify it, what you need to do? You need to do what we call the electroplating process. You can convert this into something beautiful like this. It can be silver, it can be chrome, it can be tin, but nothing beats silver. Silver is second to gold, right? In terms of popularity, and it can be shiny. So what have you got to do to change the form from red or reddish to silver? Now what have you got to do? Well, you have to do electroplating. And what do you need? Well, you need some silver metal, and you need the silver nitrate, AgNO3, to help you transform the red color cup into a silver one. See the beauty of it? So electroplating is a process of coating a thin layer of protective metal, and such as nickel, gold, silver, which do not usually corrode easily. So not only they are more beautiful, you can make it last even longer. So this is what so let's look how electroplating is being done. So electroplating is a process of coating a surface of metal with a thin layer of unreactive metal. Remember this? Electroplating is a process of coating a surface of metal with a thin layer of unreactive metal. So reactive metals like ferrum iron. So you can coat them with some other unreactive metal, so that you can preserve that cup. So here at the anode, or as the anode, we will use the metal we wish to use to plate the other object. So if you want to plate the cup with gold, so you have to use gold. If you want to plate it with chromium, then you have to use chromium. If you want to use it with silver, then you will use silver. So it depends on what finishing do you want for your utensils. So here we can just identify the anode as any material, so we just use an X. So it's up to you to decide which one do you want. If you want silver, so be it. If you want gold, so be it. So if you want chromium, so be it. Right? Then at the cathode, use the object that you want it to be electroplated. So if you want that cup to be silver cup, so use a cup. If you want a spoon to be coated, so use a spoon. If you want a plate, then use a plate. If you want your boots, your football boots, you put your football boots, and it can also be coated. You have a silver coated boot, but normally, boots we don't make it in silver, we make it in gold. So the best footballer, the top scorer, the top striker in the world will always have a golden boots. That's the reason why we call golden boots. So it's not really made of gold, but it is most likely coated with gold. Although it's molded with some other material, then finally it get coated with gold, so it looks like a golden boots. Well, you can make your own golden boots too if you want. When that's the benefit of being a student of chemistry and later become a chemist yourself. So the electrolyte we will use will be the solution of the soluble compound of that material that we want to use. So if it's silver, it will be silver. If it's gold, it will be gold. So chromium and the rest. So here we have the silver as the anode and the silver cup as the cathode. So the solution is silver nitrate. So we can buy this in a white powder form. Well, you can use to add to your solution and to make things happen. Then what will happen at the anode? The silver anode will be dissolved slowly, and later it becomes thinner and thinner. Depends on how much you like to electroplate. So the silver in solid, the moment they are mixed into the nitrate, they will give off their electrons and become silver ions. So the moment they become silver ion, they'll get attracted to the cathode. So they'll start coating the cup with the silver ion, will start be coating and will create the layer on that cathode. Can you see the difference now? At the cathode, a layer of silver metal is deposited on the cup. So the silver ion, right? When they receive their electrons, and they turn back into silver solid and stick onto the cathode. So all you need to do is take it out and place other material until you are satisfied with all the items you need to electroplate. Then finally your job is done. You need to wash them, polish them, and here you go. You have your own golden or silver coated cutleries or kitchen utensils, right? So the objective of electroplating is normally to give the object a better outlook, converting cheap stuff into something more presentable. Maybe it's too expensive to have a golden spoon, so we can compromise a gold plated spoon. It looks like gold, but well, nobody's gonna ask you whether this is gold or gold plating, right? But then the most important thing is to protect the material so that it will not become rusty. So electroplating is applied normally in tin plating, which are used to manufacture food cans. When you buy your sardines or you buy your baked beans, this kind of cans. So they need to coat the cans with tin or some other material, whichever is necessary, so that it will protect the food in the tin, so that it will not become poisonous. So it will protect the consumers. And besides preventing rusting, electroplating will give a good decorative finishing. Very nice. So just imagine a simple iron necklace. If you're gonna coat it with silver, then you have a silver look necklace. And if you're gonna coat with gold, it will become a gold look iron. Well, actually, once you electroplate it, so many things can happen. So in electroplating, the object to be electroplated is made the cathode, and the anode is the electroplating metal. That is all. Quite simple. So the end result, the silver solid at the anode will give off its electron to become ion, and at the cathode, the silver ions receive back the electron, become solid. And here you go. So you can use many metals to electroplate, right? Now people don't see electroplating as a serious thing, but let me tell you a story. About 20 years ago, I saw a company at Sungai Way. It's written there as long time ago, 20 years ago. I still remember. It's written as Zulian Marketing. Yes, Zulian Marketing. Well, you know what happened, and what do? They sell or I would say they market this gold plated jewelry. So not many people can afford the real gold, so they make do with gold jewelry. I beg your pardon, gold coated jewelry. So you know what, for 20 years, I think that company that starts at Sungai Way, I remember very well, because I saw a big advertisement written at their head office at that time, I believe, in green, Zulian Marketing. That was about 20 years ago. And you know what, all these years they have been marketing gold-plated jewelry, and you know how much they generate the income? I believe not less than $1 billion, billion ringgit. I believe so. I don't know. I don't have in fact information, but I believe so much, because as I travel on the highway, especially north towards Kedah, south, from north to south, you can see on the billboard at the highway showing, Zulian is congratulating its members, who have supported them. And looking at the numbers of people buying and using Zulian, and it has become a household name, and $1 billion ringgit is not really a big deal. I believe it is even more. So can you imagine a humble company that starts in Sungai Way eventually become a big corporate company with assets, with sales and assets worth billions of ringgit? So that is what electroplating is all about. So you, as a student, If ever you graduate and become a chemist, you can become a chemist, or if you like to be an entrepreneur, learn how to electroplate things. You're gonna make tons of money, believe me. And Julian have proven it to us in Malaysia. And I would say that chemistry is power. This is what I really mean. Chemistry is power. When you have tons of money like Julian, are they not powerful? And they make other people's life merrier too. And people who don't have the chance to become goldsmiths can become gold-plated smith. Well, anything related to gold, people get excited. So we cannot get the pure one, just get the coated one. They are just as good. So that is how important electroplating is, and the reason why we need to learn electrolysis. I guess this lesson is quite interesting, and I hope you can become a good student and pass your exam and go to university and come out with a degree, chemistry degree. Alright, so next week we will be talking about voltaic cells. Now this, if you want to become a battery manufacturer, now you need to learn this. You know, people are using handphone, a lot of them, billions of handphone, and billions of handphone will require billions of batteries, right? Here again, if you know how to produce batteries, you're gonna make tons and tons and tons of money. So until then, guys, this teacher Metza bidding you farewell and have a good day. Bye, and thank you for your time.